In this video, we're going to talk about the adrenals. When we look at the word adrenal, we see add. We're adding something to the renals, to the kidneys. It's also known as the suprarenal because the adrenals lie above the kidneys. So we have adrenal, aka suprarenal, adrenal because we're adding something to the kidneys, or suprarenal because we have found something above the kidneys. Now, if we take a closer look at the adrenal gland, we will see that the outer portion is the adrenal capsule. Okay, that's the capsule. But look at the adrenal cortex. That's the thicker part in here. That's the adrenal cortex, whereas the inner portion, I'll put an M, is for adrenal medulla. The adrenal cortex, remember, is involved with the glucocorticoids and mineral corticoids, and the adrenal medulla is epinephrine and norepinephrine. Those are called the catecholamines. So here, this is important to know for lecture and lab, we see that we have the adrenal cortex. Histologically, when we look at it under a microscope, here's the adrenal capsule, that's the outer part. Now we're going to be looking at the adrenal cortex, right? So we're taking this and we're blowing it up here. We're going to have the zona glomerulosa, the zona fasciculata, and then we're going to have the zona reticularis. So those are three main parts of the adrenal cortex. Once we're deeper than the zona reticularis, then we're down here in a deeper part, which is the adrenal medulla. The glomerulosa is going to secrete the mineral corticoid, which is aldosterone. That's involved in sodium regulation. The zona fasciculata is your glucocorticoid, mainly cortisol. Okay. The zona reticularis, these are the sex hormones, the androgens. Okay, so you need to know the three areas, what hormones they release and produce. So the zona glomerulosa is the mineral corticoids, primarily aldosterone. The zona fasciculata, the glucocorticoid, primarily cortisol, cortisone, and corticosterone, but cortisol is the biggie. And then the zona reticularis, which is the androgen hormone that's going to have its masculinizing effect, such as testosterone. Aldosterone is a major mineral corticoid secreted by the adrenals, and it's going to regulate sodium. Now remember, sodium and potassium work together. We remember early on the sodium-potassium pump. If sodium is moving in, potassium moves out. They move in opposite ways. Sometimes in diets, sodium is too high. In relationship to potassium, you get high blood pressure. So increasing potassium in the diet by itself can lower blood pressure, whereas too many people are focusing on decreasing the sodium. I think that has a lot of problems within itself, losing this electrolyte. I think it's a little bit easier to increase potassium levels. People have been trying to decrease salt in their diet for years and years and years, and we have, cardiovascular issues and blood pressure problems more now than ever before. So let's look at the RAS system, the Renin, Angiotensin, Aldosterone system. When we look at that, we're looking at Renin, Angiotensin, Aldosterone system, or the RAS system. So in this particular case, we're going to be looking at low blood pressure. Maybe the low blood pressure is coming from dehydration or a sodium deficiency or loss of blood, like a hemorrhage. So if you're losing blood, you're dehydrated, or there's a sodium deficiency, the amount of blood volume decreases, which means you're going to have a decrease in blood pressure. The kidneys don't like a decrease in blood pressure, so the kidneys are going to release something called renin. Look at the first three letters, renal. So the kidneys are going to produce renin. Whereas the liver is producing something called angiotensinogen, and anything that ends in -ogen is inactive. So how do we activate angiotensinogen? And if you look at the word, angio is blood vessel, tensin sounds like tension. So this hormone or enzyme that's inactive is going to be involved in regulating blood pressure. However, it's inactive. So how do we activate angiotensinogen? That's where the renin from the kidneys bump into it. It's going to knock off the ogen. When renin bumps into angiotensinogen and it knocks off the ogen, we're left with something called angiotensin 1. Now, if there's an angiotensin 1, it leads us to believe there's an angiotensin 2. What is it that converts angiotensin 1 into angiotensin 2? That's where the lungs come into play, where it releases ACE. ACE stands for angiotensin converting enzyme. So that angiotensin converting enzyme is going to convert angiotensin 1 into angiotensin 2, and angiotensin's job is primarily to increase blood pressure. Well, how do we increase blood pressure? How are we going to do that? Well, angiotensin 2 is going to constrict your arteries, and when you constrict your arteries, blood pressure is restored to normal. Well, what else does angiotensin 2? Angiotensin 2 is going to go to the adrenal cortex. The adrenal cortex is going to push out a mineralocorticoid called aldosterone. Remember, in the beginning, it could have been a sodium deficiency. Now, aldosterone is going to hold on to sodium. If we hold on to sodium, we're going to hold on to water. We're going to increase blood volume and increase blood pressure once again. Pretty cool, right? So this is called the RAS system. Now, we know people that take an ACE inhibitor or an ACE blocker. These are people that have high blood pressure already. They block this enzyme so that they don't get angiotensin 2 to end up increasing your blood pressure. Okay? Or people use something called Lasix, and Lasix is what? It's a diuretic. So it makes them lose water. Okay, if you lose water, you lose minerals, you decrease blood volume, and then if you decrease blood volume, you decrease blood pressure. When I come back, we're going to talk a little bit more about the adrenal gland, but I want to relate to stress and how stress can kill.